Our next presenter is Peter, who's been helping DENOG users to make the most of their network analytics. And please join me in welcoming Peter for the stage and enjoy the talk.
Well, hi, everyone. All right, this is my first time presenting at DENOG. Hopefully it won't be the last. I'm really happy to be here and really happy to present DENOG and also myself at this wonderful conference. So let's get started. What do I do? What is DENOG? And yeah, what is the presentation going to be about? I mean, you can already see it's performance measurement goes slow, but there's going to be a lot more to it. Myself, I'm responsible for customer success at DENOG, which we are a network analytics company. You might have heard of open source tools or something else, some other commercial tools. We are one of them. We try to focus on helping network operators with congestion, with visibility into the networks, and how to make faster and better decisions when they are trying to have a better network and peering. So let's get started. All right, what are we going to talk about? So, as a lot of you might be operating your own network, working for companies which have a robust or quite a large network, it's quite a challenge to monitor 20 ingress points within your network. So we had a customer who had a custom case and where we were trying to help them have better visibility into the network. So when we are talking about network measurements, latency, jitter, or anything else, basically, this is where we come into play, and this is where we are here to help them. So you might have plenty of transit points: München, Berlin, Köln, Frankfurt, or somewhere else within the world, Amsterdam, Paris, London. Doesn't really matter whether we are talking about Germany or somewhere across the globe. We want to have good measurements at these transit ingress points at our network. So here's the statement: 20 ingress points, which we want to manage, which we want to look at. How can we actually try to have better performance measurement? So traditionally, there were two ways how each and every operator was trying to measure the performance, and we are just going to try to look at them, look at the benefits of having each one of them, and then actually try to find the solution which might be better for every one of you. So one of the first approaches is that you, as an operator, you were trying to deploy your own probes at different hosting providers, whether it's OVH, whether it's M24/7 plus server, doesn't really matter what we are talking about. Basically, you deploy your own VM, you deploy your own machine, and then try to actually have some kind of interesting data from them. So you would then, what you would do is configure these probes with your own prefixes, and then see what kind of results are you going to be getting back. The problem that you would have there is that BGP decides the inbound routing, and while you might have several peering partners, transit providers, Artel, Tata, NTT, doesn't really matter. We can be talking about Aurelion, Ratten, doesn't really matter who and why we are talking about them. It's going to be deterministic. It's not going to be up to you. It's going to be up to the BGP table that you see. And even though you might want to have visibility over of all your transit, still, it's not going to be up to you what or how is it going to be happening. So you might end up with 40 or 50 vantage points to increase the probability of hitting each and every route that you want to actually look at. You can't really make a sense out of it. So you can't really guarantee that the visibility that you're looking for is actually going to be happening there. There's an alternative option, which is going to be third-party dataset providers like Catchpoint, Thousand Eyes, or Cantic, doesn't really matter who we are talking about, and they have presence all across the globe. So you can just try to buy the data from them because they are pinging your network all the time, they are pinging different addresses, but it's going to be up to them. So you can't really have a focus on what's going to happen, how is it going to be happening. You're kind of reliant on a third-party provider. And I think a lot of you in today's world, actually trying to focus on sovereignty and having your own data set, this is going to be relying on some other providers again, which a lot of times it's easy, cheaper, but sometimes you're just going to be reliant on someone else's work. So we are talking about, and I'm going to explore the third option a bit more, because that's what our customer did. Basically, they set up 2 different probes at 2 different providers. It doesn't matter where. They just basically deploy 2 VMs. But what's interesting is that they had a central endpoint with a /40 IPv6 address announced. And via each and every, you can see different ingress points, they announced the /48. So what that does is that basically, afterwards, you have a deterministic approach. So you basically can make sure that you can check for all your passes that are within the network, whether there's any latency, jitter, or quality measurements that might be going sideways. It doesn't matter what provider we are talking about or how we are talking about them. This is going to be a much simpler, more cost-effective, and usually more precise latency measurement. It really can focus on that you have actually all of the transit or peering providers you have and have them measured for sure. Otherwise, if you're going to go back to the first 2 ones, you're kind of reliant on them. So whether we're talking about sovereignty or having your own data set, I think, or at least in our opinion, this is what we would recommend to go forward with. But obviously, there is some comparison that we can talk about, whether we're talking about external hosting, our hosting, or having a vendor that's going to provide us. I don't think I should spend a lot more time on this one, because everyone can probably read it, and obviously this is going to be, the slides are going to be sent through afterwards. So let's just get through. What are the problems of probe-only monitoring? So this is going to be only one data set of yours. And you might want to correlate the data with other data sets. So whether we're talking about flow, BGP, SNMP, or anomaly detection, it's actually really important that you are within your company not working in silos, but the same goes along with the data set, that you try to correlate every information that you collect with every information that you have available. You might have wonderful tools which does single tasks here and there, but it's really going to make your life easier if you have one single source of truth where you can actually correlate the information that you're having from one tool with another one, and you don't have to go back and forth in between trying to figure out what's really happening within the network. So how do we actually connect these dots? I think this is where we came into play, and how actually in real life you can actually see it. So basically, we are correlating BGP, ISIS, SNMP, and flow data. So everything that basically a network operator would have as their data set. And we integrate also the probe data set that we were getting it. So how do we actually correlate it? We collect the probe metrics, assign the flow metrics as well, that we are correlating it. And we have an anomaly detection part of our software, which does the correlation of the data and can also look at anomalies when we're looking at only probe data as well. So let's look at one of the examples. So we're talking about Steam. Plenty of you have already seen Steam traffic coming into the network. Sometimes there's an update of CSGO, sometimes there's an update of some other games. Doesn't really matter which one we are talking about, Fortnite as well. And then how does it actually correlate with the flow, and how does it actually correlate with the probe data? So what we can see here is anomaly in the probe data. What we see is there was a massive surge of Steam traffic coming into the network, and this probe detected a poor performance, and there is this green line over there, which just basically spiked during that time. And what that meant for us is that basically we are outside the threshold that we would deem acceptable. This is something that you can self-define yourself for your own needs. So you might want to have a more wider or a shorter threshold, but this can be up to you how you want to define that. So then obviously you get the email alert saying that there was something happening in one of your peers or transit providers. In this case, it's Aurelion, but this could be anything, Raton or Tata, or we can be talking about GTT. Doesn't really matter. This is just an example. And you obviously see as well London. So we are talking about one of our locations. So what was going on there? As you can see, we are seeing the router and the provider as well, and we see all the applications that are coming into the network. This is also that we are collecting DNS data, so with that we are actually able to assign what kind of applications are coming from these different networks and network providers. And what was interesting, if we would be looking at only at the NetFlow data, which you can see on the left here, there wouldn't be anything not normal, because all these ports, all these interfaces have been pretty much utilized, and it's just been a little bit, the time has been just a little bit more extended. But the traffic patterns pretty much fit the same time frame. What is interesting is that once the Steam traffic started to come in, so we are talking about this year, March, through Aurelion, when the Steam traffic appeared, that meant that some of the quality of the traffic actually went down. So this is how and why we mean to correlate the data that you have. Because then you're going to be able to see that, OK, I see that there is a quality issue that I have. What's really causing it? And then you go into the tool, and then whatever tool you have, and then you start seeing, OK, it's actually Steam that went into my network and just kicked out some of the other providers that were hosted on that network. And afterwards, you can actually have some diagnostics what was going on there. And then you can obviously have a detailed more detailed investigation, what was going on there, and that how it has affected any of your providers. So I think it's really interesting and also really useful for you to have this kind of visibility over of your data. So this is just one of the real-world example. This is actually Blacksmith Wukong. So some of you have already played this game. It's quite a popular RPG. And it just, well, there was a multi-terabits of traffic bursting through one of the ingress points. We basically triggered the anomaly. There was a flow correlation to it. And then you could actually get into detailed investigation. What's the outcome, or what's the solution? Obviously, you're going to have to reach out to the providers that you're connected to, ask them either to have bigger capacity or use some other ports to reroute the traffic, or you can try to have more deterministic paths. So some of these applications are reaching you via some other locations, not only London, but Frankfurt, Amsterdam, Paris, doesn't really matter. But let's look at some of the other examples. YouTube. So here we have another alert. We are talking about some latency measurements, and here what we can see, the latency has increased quite significantly compared to what we had before, and then there was an alert triggered again. So then we are doing again the flow correlation, that the YouTube traffic through that ingress point has spiking, but only at some of the locations that we are seeing. And then you can go into the detailed investigation, and then when we are looking at the handover aliases, which are the ones that are sending the traffic directly into the network, are actually used for during the peak hours. And what we start to look into it, what's causing these spikes, is during night hours when there's a lot of people using Google searches. There's a lot of, nowadays, these AI texts, or these little short abbreviations that tell you when you search for how do I do my taxes in Germany, you have a little description over there, and that's the kind of traffic that's actually peaking there during those times, and it affects YouTube quality. So then you can actually talk with them, whether it's affecting only you, whether it's affecting all other providers as well. You're the only one. Is there something that you can do about it? But obviously, this is some kind of information that you actually would need to have a more detailed analysis of the word, of what's going on, or how is it actually happening. The same as well, there's plenty of users within the country, within your network, using YouTube, so it's going to be quite important when they're complaining to know what exactly is going on. So you need the triggered anomaly, you need a correlation, and you need a detailed investigation. So actually, I think you've seen why or how is it important for each and every one of us to have these detailed investigations of our probe data. But again, as I mentioned before, if you're looking at single sources of information just by themselves, it's not really going to be helpful. Because you might be looking at information here, you might be looking at information there, but you need to actually couple everything that you have available to make use of it. Whether we are talking about probes, flow, anomaly, or whether we are talking about SNMP, utilization, thresholds, whatever else kind of metrics that we can talk about. It doesn't really matter. It's important that whatever thresholds or whatever metrics that you're collecting can be coupled together, and you don't have to spend hours to find out what's really causing the issues or the problems within your network. Obviously, this is going to be cost-effective. This is going to be time-effective as well. And I think nowadays, this is one of the challenges that each one of us faces, is time, how we can actually manage our time. If you're going to have to spend hours just to debug one of the problems that's been happening in the network, if I would go back to the Steam use case, how much time do you actually need to spend to figure out what's going on? Because if I go back, you pretty much see the same amount of traffic. It hasn't changed, but without having the application information of your traffic, you won't really be able to see what's going on within your network. You might guess, and there is plenty of guesses that might be good, that might be false. But in the end, both your management, your coworkers, and yourself want to know the real truth, the real knowledge, and how you can actually improve your network. How can you improve your visibility? What's going on within the network? And I think that's the most important part of our jobs, to make it ourselves more easier, better, and more resilient. So let me just go back. And yeah, so what we would recommend for ISPs, but it doesn't only apply to ISPs. It does apply to any kind of networks, mobile networks, ISPs, or hosting companies as well. When they want to improve their latency, when they want to improve their measurements, it's important that they are trying to strengthen the network capacity. When they see the issues arising here and there, they can actually talk to their providers to have more visibility into the network, to have more capacity, whatever else we're talking about. We also need to talk about content delivery. When we see that there's a major update coming from, let's say, Fortnite, which are causing nowadays real peaks, or whether we are talking about the Champions League game. Champions Leagues, whether in Germany delivered by Amazon or delivered by Fastly, Akamai, doesn't really matter. You need to be prepared for all these events, that you have enough capacity for all these kind of events. And then you have to make sure that you have the information that what and how does it actually affect, whether we are talking about your end customer experience, your network experience, does it actually fill up the capacity in some of your pipes in between the cities, between Berlin and München. You need to have the data set in order for you to actually try to make your network more resilient. You can obviously optimize the traffic, because if you see that there is traffic coming in from different kind of providers, you might be asking, hey, can you actually just use only one provider and we are going to increase the capacity with them instead of sending it via Akamai, Amazon, and Fastly? Can you actually only use Akamai, or can you actually use Amazon? We are not here to give recommendations who they should be using or how you should be approaching it, but it's important that you have this dialogue, and this dialogue with these other partners of yours don't die, and you have an open conversation, and then you can actually improve your network and improve the content delivery. But for that, you actually need to have the visibility, and you need to know that whether there's a latency issue, whether there's a probing issue, whether there's jitter, any kind of quality measurement that you might be collecting, you need to be aware of that in order to have the right visibility. So this would be the whole idea of the presentation: to have the right visibility, to be working together, and to be actually have an open dialogue about it. So I still feel like I have more time. Try to not rush through the presentation, but I'm here for if there's any questions.
Thank you, Peter, for these insights. We have some time for questions. Are there any questions in the room? Oh, there's one.
No.
I give you the microphone. Please state your name and your affiliation.
Hi, I'm from Brita. So I have a question about your data here. So you mentioned something about correlation, and based on that, you can estimate where is the problem. What about causality? So, for example, you mentioned when there is a high traffic from Steam that could impact other applications. Mm-hmm. On the other hand, for example, the example of AI text, maybe that could be impacting YouTube, maybe not so. Are there any metrics to look at besides correlation in order to say, okay, that is the thing causing my problem? Or would it be only your best guesses in order to handle it?
Yeah, so if you're talking about the AI thing, that was just something that's a best guess what was going on. Because if you were talking to Google, what was causing the problems with, you can actually have the conversation, and they might let you know, like, that's actually what's causing the issue. So that's how we got to the information based on these open discussions. When we are talking about the other use case with the Steam use case, that's actually something that we can see clearly in the traffic, because the utilization levels of the passes haven't really changed. So the ports were still at the same level utilized. But we still got the alert that there was some jitter in the traffic. I think this is jitter, no latency. So here we got the correlation in the tool itself that it's actually the latency that's been affected based on these graphs, based on actually the more Steam traffic that the network was receiving. I hope I answered your question.
Kind of, yes.
Okay.
I have a follow-up question also. So, how to handle such traffic in order to be proactive and not reactive? So that's probably an RFO analysis in order to say, okay, we had a problem. What happened there? What if I want to have something like alarms or something like that? How would I?
Obviously, this is a reactive approach. Trying to, solve the issue once it's there. What you can try to do and have enough capacity, that's always something that you can easily do and try to manage with whether we're talking about Aurelion, whether we're talking about any kind of transit providers, to have enough capacity. And also what you can do is to have in a future predictive path to know how much traffic, how much capacity you will need at those different locations. So if you see that there's a clear traffic increase or surge over time, then you will know that you actually need to increase the capacity at those places. So sometimes it's going to be reactive because you haven't seen, for example, Amazon delivering Champions League game. But once it's happened, you can take, first of all, it's going to be a reactive approach, but then you can proactively approach it and be like, hey guys, are you going to be hosting more of these games, or was this a one-time thing happening?
Thank you.
So are there any more questions in the room?
Yeah.
Oh.
Oops. Yeah.
Freddy Künstler, Init7. Yes, this one. So you propose to use like 20 prefixes to propagate separately via each ingress point. So how do you do that with IPv4? I mean, we still have IPv4, as we all know, unfortunately. Yeah. But that would waste up to like /19 almost.
Yeah, that would be quite a challenge to do so. And we've only did it with IPv6 so far. That's what we've seen. So I would love to answer it how you can do it with IPv4. If you have the address space available, go for it. I think that would be the best answer. But no, sadly, I think there is not enough address space for it. So I'm not sure to give you an honest answer how that would be feasible.
So I think we have enough time for another question. Anyone? No? Is there anything in Venulus? So no questions online. So, all right. that's a wrap for this presentation. Thank you very much, Peter. And we will write back